Hello guys and welcome back. So let's talk about the destruction workflow in Houdini. And the first starting point we have obviously is a mesh. Now this mesh depends on where it's being created and which department makes it. It may need to go into an extra step for preparation, destruction preparation. The mesh for destruction needs to be watertight, so everything needs to be enclosed, and will need some extra details that are not visible at the outer layer. So for example, if you have a wall and let's say this is just bricks like that from the left side, or let's say a concrete wall, when you in CG, when you work with it, you just create a plane and assign a texture with the bricks. But when it comes to destruction, you have to have an actual geometry inside and then a thin layer to represent the concrete that is stuck to it, and another concrete layer as well. So this extra processing may need to be done in Houdini or in other packages to add the actual structure. So if you have a house that is made of wood, you need to build that construction or the wood structure so you get proper behavior and proper details. So we're going to talk about this in Houdini to show more examples. Now once we have the mesh and it's ready, we take it to the next step, which is fracturing. So let's say we have a wall like that, just a grid, and then we want to fracture this. So the next part would be to take that and fracture it. Now there's many ways, well, there's not many ways, there's 3 ways to take a geometry and fracture it. One, which is the easiest and most stable solution, is to use the Voronoi algorithm, which we are going to be using primarily in this workshop. And then the other solution is to use the first solution is to use the Voronoi, which can take an input geometry. We place a point in space, and then those will be used as the Voronoi cells. So it will fracture them in a way that each one of these guys represents a cell. And the Voronoi algorithm, the main reason it's very solid is because it generates non-concave meshes. So everything we get is convex, so which is pretty easy to work with in destruction. And I'm going to talk about this in more details. Now, apart from the Voronoi, we have the new tool in Houdini for doing booleans, and this can also create very interesting details. The main downside with this is that we get concave meshes, so we have to deal with that, and by default Houdini doesn't have anything to work with that with the convex mesh, with the concave meshes. So it adds a little bit of complication and may be hard to work with in the sim. The next one, the next workflow for creating destruction or fracturing the mesh is using VDBs, and this is something that can be done for high-res close-up shots or meshes that you need a lot of details on them. Now the same result can be achieved as well using the boolean, but that's another option that we can use. For this week, for this workshop, we're going to be primarily focusing on the Voronoi, and then towards the end I'm going to show you guys how you can take it further and use the boolean tool to fracture the mesh. Cool. So now we've taken a flat grid or a wall, let's say. We fracture it into mini pieces like that. The next part is to generate what we call a constraint. What the constraint is, it's a connection that Houdini uses to know how the pieces are connected together. So in this case, the constraint will be an actual line connecting the centroid or the center of each of these pieces. Okay, so we have an algorithm, we have a tool in Houdini that checks based on the neighboring, and if there is two adjacent pieces, it connects them with a line. This information gets passed to the RBD sim, which knows how to tie and link the pieces together. Cool. So once we have this data, we have the fracture geometry, which is this, and we have the constraint network, which looks like just lines, basically. Both of these, both of this data gets passed into the RBD sim. Now, Houdini, this is in the DOP network, so we have to pass in the data and then run the sim and get the data out. So we get the data back. The inside the RBD sim, there's multiple solvers available in Houdini, one called ODE and the other one called Rigid Body, which is the native Houdini solver, and the latest one, the newest one, is the Bullet solver, which is the one that we're going to be focusing on. Now, the Bullet solver is much faster than all the other tools available in Houdini, and that's what's being used primarily, and everything that is being developed now is using bullets. Now, Side Effects implemented something to help deal with passing heavy geometry between the SOP context into the RBD sim. And this data type is called packed primitives. And what it does is it takes a lot of pieces and converts them into points. So all that we're going to be passing to the RBD sim is an actual set of points, and then the constraint network. And here Houdini will figure out the OpenGL display that it needs to show to the user, and then under the hood it's gonna use these packed primitives and efficiently work with them. That's why we can do hundreds of thousands of pieces interacting together, and it's still very efficient and light. Now, once we run the RBD sim, we're going to take back, extract back not the geometry, but these points, okay? And these points will have transformation information on top of them. And then what we're going to do is we're going to take this mesh at frame 1 and then apply the animated points to them to deform them. So we're going to send to the RBD sim the points, the constraint, run the sim, and then extract the points again. We can also extract other information from the sim, like the impact information when a constraint broke and stuff like that, and use that to trigger further post-process on the mesh. If we wanted to emit debris or do anything to the mesh, we have that information if we wanted to. Now, one thing that comes to mind with this fracture workflow is that there's no dynamic fracturing, and that's something we're not going to be doing in Houdini, and I have never seen it done in production, because you don't want a new geometry to be created inside this part. You want to have a predefined set of geometry, you process that, and then you get the data up. If we start creating data here, it's going to be completely random, and it's not something that we can control. Now, it's going to be able to fracture, localize, do fracturing based on impacts, which is something that could be interesting, but with this workflow, with a pre-fracture workflow, and that's what, as far as I know, is how most of the movies and the VFX work is being done right now. We pre-fracture the mesh and then we pass it through. We're not going to do any dynamic pardon me, we're not going to do any dynamic fracturing inside the RBD sim, and I highly recommend not to do any of those workflows. Okay, cool. So let's continue in the next video. Thank you guys for watching, and see you in a bit.